Question 7. So you have to calculate the molecular formula. So nicotine is 74.1% carbon, 8.6% hydrogen, and 17.3% nitrogen by mass. And its molar mass is 160 gram per mole. So determine the molecular formula of nicotine. So based on the mass percentage given, you have to calculate the molecular formula of nicotine. First one, we have to find the smallest ratio or empirical formula for nicotine based on the percentage. Okay, so kita buat apa? Kita buat table lah. Okay, simple one, we do the table. So we have carbon, hydrogen, and nitrogen. Okay, first we write down the mass. Okay, mass of each element. So mass of carbon is 74.1. Mass of hydrogen is 8.6. And nitrogen is 17.3. Okay, so based on the mass, we can get the mole. Okay, so moles equals to mass over molar mass. Okay, so 74.1 divided with 12, so you get 6.17. Okay, hydrogen 8.6 over 1, so you will get 8.6. And nitrogen 17.3 over 14 equals to 17.3 divided with 14, you will get 1.23. Okay. Okay, so next step, you have to find the smallest mole. So you have to divide with the smallest number of moles. So from 6.17, 8.6 and 1.23, so the smallest moles are 1.23. So you have to divide all this number with the smallest number of moles. So 6.17 divided with 1.23, you get 5. 8.6, you divide with 1.23, so you get 8.6 divided with 1.23, so you get 6.99 or 7. Okay, and 1.23 divided 1.23 is 1. So the empirical formula for nicotine is C5H7N. Okay, so this number refer to the atom carbon. 5 refer to the atom carbon. So you have 5 atom carbon, you have 7 atom nitrogen, and 1 atom nitrogen. So this one is the empirical formula. Empirical formula meaning that they refer to the simplest whole number ratio of atom in a compound. But based on the question, you have to determine the molecular formula. So next, apa yang kita perlu buat ialah we have to find the ratio. Okay, ratio untuk cari molecular formula. So based on the empirical formula yang kita kira tadi tu, C5H7N. So kita kira dia punya molar mass. Okay, so molar mass for C5H7N is, okay, so ni atomic number for carbon. So 5 times 12 plus 1 plus 7 plus nitrogen is a 14. So you get 81. Okay, so from the molar mass of the empirical formula, kita boleh cari dia punya ratio. Okay, so you have the molar mass, molecular formula dia tadi berapa? Molar mass dia ialah 160 divide with 81. So you akan dapat ratio dia ialah 2. Ratio ni yang mana? Sebenarnya tadi you have empirical formula C5H7N terletakkan dalam bracket X. Okay, so kita nak cari nilai X ni lah. So X ni refer kepada 2. Okay, so bila you ada C5H7N in bracket 2, so you boleh cari dia punya molecular formula. So molecular formula dia C10H14N2. So kita darabkan nombor kecil ni dengan nombor di luar bracket. Okay, so multiply all the atoms, okay, in subscript by the ratio to find the molecular formula. So the answer is C10H14N2. Okay, next question, question number 8. So you have to balance the equation below. So you balance lah, kiri dan kanan. Okay, mesti sama. A, you have nitrogen molecule react with hydrogen molecule produce NH3. So this one is a reactant and this one is a product. So the number of atom between reactant and product must be same. Okay, balance between this molecule. Okay, so you have nitrogen 2, hydrogen 2. At the right side, you have 1 nitrogen, 3 hydrogen atoms. So meaning that you have to put here 2. So you have 2 nitrogen atoms, same with the reactant, but you have 6 atom of hydrogen. So you have balanced the hydrogen in reactant. So we put 3 in front of the hydrogen molecule. Okay, so balance equation for A is N2 plus 3 hydrogen produce 2 molecule of ammonia. Okay, B, NaCl plus F2 produce NAF plus Cl2. Okay, so you have 2 atom chlorine has a product, so you have to balance chlorine in the reactant. So you put 2 here and then 2 Na, then we put 2 here in the product. So 2 Na, 2 Cl and 2 F2. Okay, so this one is the balance equation for B. And C, H2 plus O2 produce H2O. Okay, so oxygen ada 2 in the reactor, and then we put 2 in the product to balance the oxygen, and then we put 2 in front of the hydrogen atom to make the balance equation. Alright. Okay. Next, we look at the last question. Question number 5 is about the limiting reactant. Okay, so you have to calculate the moles and to find the limiting reactant. Okay. Okay, question 9. Consider the following reaction. So you have 3 mole of silicon react with 2 molecules of nitrogen to produce 1 mole of Si3 and 4. So A, when 21.44 moles of silicon react with 17.62 moles of nitrogen, so how many moles of Si3 and 4 are formed? B, you have to find the limiting reactant, and C, you have to calculate how many moles are left over at the end of the reaction. So this question refers to the limiting reactant. Okay, so A, kita lihat dulu dia punya equation. So 3 mole of silicon react with 2 mole nitrogen molecule produce 1 mole Si3 and 4. So if you look at this equation dia punya ratio adalah berbeza. Okay, tak sama. Maksudnya bukan ratio 1:1 to produce 1 mole. Ratio dia adalah 3 mole silicon react with 2 molecule of nitrogen produce 1 mole of silicon Si3 and 4. So based on the equations given, A, when 21.44 moles of silicon react with 17.62 moles of nitrogen, how many moles of Si3 and 4 are formed? So you have to calculate the moles of Si3 and 4 form. Okay, so bermakna you ada 21.44 moles of silicon, you darabkan dengan 1 mole of Si3 and 4 divide with 3 mole Si. Ya, kita nak cari dia punya ratio 1:1. Okay, so darab silang. So you akan dapat 7.147 mole Si3 and 4. Okay, so kita buat satu-satu. First, kita buat the first reactant, silicon. And then kita calculate pula daripada nitrogen. So yang kedua, 17.62 moles of nitrogen times with 1 mole Si3 and 4 divide with 2 mole nitrogen. Okay, so you akan dapat 8.81 mole Si3 and 4. Okay, ini tadi boleh cancel, ini tadi boleh cancel. Okay, based on the number of mole, kita perlu cari yang paling sikit. Okay, because of yang paling sikit itulah penentu kepada berapa banyak produk kita dihasilkan. So between these two, yang paling sikit ialah from silicon. So meaning that moles of Si3 and 4 are formed ialah 7.147 mole. So ini jawapan. Yes. Okay. Alright. So kita tak boleh ambil yang ni lah. Okay, kita mesti ambil nilai yang paling kecil. Because of nilai paling kecil ni adalah limiting reactant. Dia yang akan penentu berapa banyak produk kita akan dihasilkan. Okay, so B, what is the limiting reactant? So based on this calculation, so kita dah tahulah. Sebab kita ambil the smallest number of mole tadi daripada silicon. So bermakna B, limiting reactant dia ialah Si, silicon. Alright, C, how many moles are left over at the end of the reaction? Berapa lagi moles yang tinggal selepas tamatnya reaction itu? Okay, so kita tahu yang ini ialah limiting reactant. Dia akan habis dulu. Okay, kemudian kita akan ada extra dia. Okay, ini ialah excess reactant. Okay, kita nak tahu berapa balance dia. Senang saja, kita ada excess reactant ini daripada nitrogen. Okay, so nilai moles of excess reactant ni kita akan tolakkan dengan moles of limiting reactant. Okay, C, tadi kita ada excess reactant kita ada 8.810 mole minus with limiting reactant tadi. Okay, moles of limiting reactant kita ada 7.147 mole. So bermakna you akan dapat 1.663 mole. Okay, so ini untuk 1 mole. Kalau based on the equation you ada 2 mole of nitrogen molecule. So you kena darabkan 1.663 times 2. So you akan dapat 3.326 mole nitrogen. Okay, so inilah jawapan dia. Berapa lagi molekul yang tinggal. Alright.